Alright, example 7. Given x squared plus y squared equals 25, we want to find the second derivative. Alright, so the first derivative, we would take the derivative of this whole equation, and again we're using implicit differentiation because this equation, we could solve for y here, but we're going to just do it this way. Okay, so when I take the derivative of x squared with respect to x, that's going to be 2x. When I take the derivative of y squared with respect to x, that's going to be 2y dy dx. And when I take the derivative of 25, that's going to be 0. Okay, now I'm going to solve for dy dx. So I'm going to subtract 2x from both sides, and I get 2y dy dx equals negative 2x. Then I'll divide both sides by 2y, and I'll end up getting dy dx equals negative x over y. Now I want to take the second derivative. So to take the second derivative here, it's going to look this way. Okay, and then I'm going to take the derivative of the first derivative. So this is going to be the quotient rule. So it's going to be the numerator times the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. Notice the derivative of the denominator, that's y, and I'm taking this with respect to x, so that's going to be 1 dy dx all over the denominator squared. So let's try to simplify this a little bit. The second derivative is going to be negative y plus x, and I'm going to replace dy dx with this negative x over y all over y squared, and then this would be negative y plus, minus x squared over y all over y squared. And then I could multiply through here, top and the bottom by y. This would give me negative y squared minus x squared all over y cubed. And then notice here I can factor out a negative 1, leaving me with x squared plus y squared all over y cubed. And notice here x squared plus y squared is equal to 25. So I can substitute here negative 1 times 25 all over y cubed, which is negative 25 over y cubed. This would be the second derivative of this function. Alright, let's take a look at this next one. Okay, find the derivative. If I asked you to find the derivative of this, you definitely could do the chain rule, which incorporates the quotient rule, power rule, all kinds of good stuff in there. Okay. An easier way to do this would be to take the natural log of both sides of this function and notice I'm going to write this as a power instead of a radical, and now expand this using our log properties. So the natural log of y equals the natural log of this numerator here would be 2x. Now let's not skip steps here. Let's make this x minus 2 squared, and then the division here will tell us minus the natural log of x squared plus 1 to the 1/2 power. And now we can use the power rule for logs. So I can put 2 out in front of the natural log, and I can put 1/2 out in front of the natural log. And let's see, now I can differentiate, okay? And we're going to differentiate this so this right here, the natural log of y, if I take the derivative of that, that's going to be y prime over y. This side is going to be 2 as the constant. This is going to be u prime over u. So u is x minus 2. If I take the derivative of u, that's going to be 1. Minus 1/2. Same thing here. The rule is u prime over u. So u is going to be x squared plus 1. U prime would be 2x. Now I can simplify this a little bit. I can make this 2 over x minus 2 minus, notice these 2's cancel out, so this would be x over x squared plus 1, y prime over y. And then to get y prime by itself, I could multiply both sides of the equation by y. And then we know that y is this guy. Y is this x minus 2 squared all over the square root of x squared plus 1. So dang it, I erased that. My bad. Let's see, let's do this again. Oh, no. Sorry, that's previous work. So this would be y prime equals 2 over x minus 2 minus x all over x squared plus 1, where this y is going to be x minus 2 squared all over the square root of x squared plus 1. That would be our answer. Okay, so logarithmic differentiation will definitely make this a lot easier. If you tried to do the quotient rule here, you could try it. It would be a nightmare.